Hello and welcome to Mathematical Coaching Center. Today in this video we'll start our discussion on continuity. But to do that we must have some basic concept of limit. So I suggest you to see the video that I've made on limit. The link will be given in the description, or else you can see some kind of suggestion up here. You can click on that suggestion and see that video. And if you have problem in learning mathematics, then consider subscribing this channel. So without any further delay, let's begin. So let us try and understand the term continuity. Okay, let us see what is the literal meaning of continuity. So continuity means which is continuous or unbroken, which is continuous or unbroken. Suppose there is a figure like this and you need to make this figure. Okay, and if you start making it from this point, and you can make this figure without raising up the pen. Okay, so if I start drawing it, I can draw this without raising my pen. So this is a kind of a continuous figure, you can say. In mathematics, we will try and discuss a function which is continuous. So in mathematics, we will try and discuss continuity on function. So a function is said to be continuous if it does not have any abrupt changes in value. If the function does not have any abrupt changes in value, then that kind of function is known as continuous function. So let us understand what abrupt changes in value mean, okay, with the help of example. So let us take one example where fx is defined as fx is equals to 1 where x is greater than 0, fx is equals to 0 when x equals to 0, and fx is equals to minus 1 when x is less than 0. Let's try and plot this in the graph paper with x-axis and y-axis. So we'll be plotting x on the x-axis and fx on the y-axis. So let's make few points like 1, 2, 3 and 4 here on the positive x-axis. This is -1, -2, -3 and -4, and we have the same thing on y-axis, 1, 2, 3 on y-axis, positive y-axis, and -1 and -2 on negative y-axis. And let's try to plot this here. So now let's see what happens when I take x is equals to 1. When I take x equals to 1. So if I take x equals to 1, so this value of x is greater than 0. So the value of fx will be 1. So I'm taking x as 1, so it will be here, and fx will be again 1, so it will be here. So I'll get some values somewhere here. This is the point 1 comma 1. When x is equals to 1, fx is also equals to 1. Again, if I take x to be 2, again that will give us x is greater than 0, so fx will again be 1. So x is 2 here, so f1 fx is 1. So this is the other point. Again, if I take x equals to 3, then again fx will be 1, and so on. I'll keep on getting points here. So there, I guess, will be a straight line passing through this 3 points. Now let's try and see what happens when it is 0, when x is equals to 0. Now if I take x equals 0, the point that I'll get will be 0 comma 0. When x equals to 0, fx will again be 0, so the point will be 0 comma 0. So it will be somewhere here. Okay, and for any value just greater than 0, close to 0 but it is greater than 0, so somewhere I'm talking about values somewhere very close to 0, values of x somewhere here. Okay, so when it is greater than 0, fx will again be 1, so the point will lie somewhere here. Okay, the point will lie somewhere here. Therefore what I'll do is I'll make a transparent circle here and a straight line indicating that this point is not included. That means 0 comma 1 is not included, and the rest of the point, that is 0 0.001 comma 1 and everything else are included. Okay, so this is a kind of straight line that we get. This transparent circle means that this point is not included. Only 0 comma 1 is not included. Rest of the point that is very close to 0, all the other points are included. Again we will do the same thing with the negative part of x-axis. Now if I take the value of x to be minus 1, if I take x to be minus 1, so x is less than 0, so fx will be minus 1. So x is minus 1 and fx is also minus 1. So minus 1 comma minus 1 will be somewhere here. If I take x equals to minus 2, fx will be minus 1 because x is less than 0. Again it will be minus 2 comma minus 1 and minus 3 comma minus 1 and so on. It will go on like this. So there will again be a straight line, but again 0 comma minus 1 is not included. So what I'll do is I'll make a transparent circle and there will be a straight line passing through all these points, which indicates that all the other points are included, whereas this point here 0 comma minus 1 is not included. This is the kind of figure that we will get for fx. Now to understand it more properly, let's try and remove the x-axis and the y-axis. Okay, so this is the kind of figure that we get. Now my question is it possible to draw this entire figure without lifting up the pen? So if I start drawing it from here, I reach this point, then I have to draw one point here 0 0, then again continue my drawing from here and so on. But I see that from here to here I have to lift my pen, and from here to here again I have to lift my pen. So this figure, it seems, is not continuous. That means the function fx is not continuous because there is an abrupt change in values from minus 1 to 0 and 0 to 1. Okay, so this is an abrupt change in value, but this is a geometric approach to a given problem. So every time to make a graph, to plot this in a graph paper and solve it is not possible. So we must have an analytic definition to solve this kind of problem. So now to do that, let's try and see these points. So the point here is the value of fx when x is very close to 0. While making this, I said that this is very close to 0, but x has to be positive. Okay, so it means that it is a value of x that is tending towards 0 plus, and this point is the value of fx when x is tending towards 0 plus. Again the same thing here, this is the point when the of fx when x is equal to 0, and this is a point of fx when x tends to 0 minus for negative values. We got this. This is very close to 0 but not 0, okay, but less than 0, so 0 minus. Now what if these 3 points lie at the same place, something like this? Now can we say that I can draw this entire figure without lifting up the pen? Is it possible? So I can see here it is possible to draw this entire figure without lifting up the pen. So now I have to see a value of fx at x tends to 0 plus. I have to see the value of fx at x equals 0, and I have to see the value of fx at x tends to 0 minus. So what are the values that I'm talking about? So I'm talking about values like right hand limit, the value of fx as x tends to 0 plus, the value of fx at that point x equals 0, and the value of fx at x tends to 0 minus is the left hand limit. That means if I can solve and find out the left hand limit, the right hand limit, and the value of fx at that point, and if all of these values are equal, then we can say the function is continuous. So hence a function is continuous if the left hand limit, the right hand limit, and the value at that point are equal. So now we can conclude this discussion with a definition of continuity. So the definition of continuity says a function fx is said to be continuous at the point x equals to a. So it says a function is said to be continuous at a given point x equals to a if, okay, and the point a should be a point on the domain of definition. If first thing is fa is defined, the function must be defined on the point A. That means fa must give us a finite value. It should not be undefined. Okay. Next, the limit x tends to a fx exists. So this limit exists means the left hand limit and the right hand limit must be equal. Okay, limit exists means left hand limit must be equal to right hand limit. And finally, this values must be equal. The value of limit and the value fa must be equal. That is same as saying the left hand limit, that is limit x tends to a minus fx, the right hand limit, that is limit x tends to a plus fx, and the value at that point must be equal. So this is the definition of continuity. I hope that this video was helpful in understanding the definition of continuity. So in the next video, we'll continue our discussion on continuity and we'll be solving few problems with regard to continuity. So to stay updated, subscribe to the channel and turn on that notification bell. Thank you for watching and have a good day.